Alright, for this video assignment for our seminar class, we are to evaluate these two problems. Alright, the first problem is from Chapter 4, Lesson 8, practice problem number 92. Alright, we're given the derivative of y with respect to x equaling 10 minus x, and they're giving us an initial value of y of 0 equaling negative 1. With that being said, they want us to find the general integral and then plug in the original x value in order to find its constant c. Alright, to start off, we're going to take the integral on both sides. Okay, and that's going to yield y equaling 10x minus x squared over 2 plus a constant c. Alright, when I plug in 0 into the equation in order to find a constant c, negative 1 equals 10 times 0 minus 0 squared over 2 is still 0 plus constant c. And if that's the case, if that's 0 and that's 0, then the constant c must equals negative 1. So the derivative, we can plug this back into the equation, and we get the integral of dy dx equaling y equals 10x minus x squared over 2 minus 1. For 5.2, number 14, we're asked to find the sigma notation of the following series. Alright, so first we denote sigma, which means the sum, and start value. It doesn't really matter where we start, but I'm going to start at k equals 1. Alright, the top value is to be how many times we're going to add a number into our series, and since we have 1, 2, 3, 4, 5 numbers, we're going to do it for 5 numbers. Okay. Alright, in this problem, this place right here is where we put a rule that denotes what's getting added. So say if I added one where it was counting just 1 plus 2 plus 3 plus 4 plus 5, then for each k value there would be a number corresponding to each of these values. This would be index 1, this would be index 2, this would be index 3, this would be index 4, and index 5. And we can write a rule for each value of k. And at this point, that would be a value of k for each value indexed at each point. Since this is just half of this, we can say that this equation over here can just be 2k, because you'll see that this summation indexed at 1 would be 2 times 1, which is 2. 2 would be 2 times 2, which equals 4. And at 2, at value 3 equals times 2 equals 6. Alright, so with that we are able to denote sigma notation for this summation to be this right here. Alright, and these are the answers to these two problems. Thanks for watching.